It is increasingly common for modern airlines not to own their aircraft, but to lease them instead. Leasing aircraft rather than purchasing them reduces upfront costs and gives airlines the flexibility to quickly adjust their capacity to meet demand, making it an attractive option for companies in volatile market niches. At the same time, airlines that do own their aircraft can take advantage of this system by leasing out surplus planes to other carriers, allowing the aircraft to continue generating revenue even when demand is low. In 2005, Air New Zealand purchased several new Airbus A320, 3 of which were immediately leased to its own low-cost subsidiary, Freedom Air International. Freedom Air operated the aircraft for about a year, until Air New Zealand decided to sublease 2 of them, one of which went to XL Airways Germany. And it is at the end of this lease that our story begins today. November 27, 2008, Perpignan Rivesaltes Airport, France. It's 10 a.m., and here, the A320 leased by XL Airways Germany from Air New Zealand is waiting to depart on a test flight conducted by Air New Zealand to ensure the aircraft is in proper condition for return. The aircraft has already been repainted in Air New Zealand's livery, removing the German airline's colors. XL Airways Germany, based in Frankfurt and owned by an Icelandic investment bank, specialized in offering all-inclusive vacation packages to holiday destinations in the Mediterranean and North Africa, a relatively volatile business model that made leasing aircraft more attractive than purchasing them. The A320 spent 2 uneventful years with XL, transporting groups of German tourists to and from places like Sharm el-Sheikh, Marrakesh, and Heraklion. The aircraft was withdrawn from service on November 3, 2008, when the end-of-lease clauses came into effect. Under the agreement with Air New Zealand, the aircraft was to be returned by November 24th, following a combined airframe inspection, a full inspection of both engines, repainting in Air New Zealand's livery, and an acceptance flight to verify the aircraft's systems were functioning properly. The German airline contracted a company called EAS Industries, based at Perpignan Rivesaltes Airport in the coastal French city of Perpignan near the Spanish border, to carry out the maintenance. The aircraft was ferried there from Frankfurt on November 3rd, and the inspections, which lasted several weeks, proceeded as planned. XL Airways had painted the aircraft white, adding large blue XL logos on the fuselage, tail, and engines. Air New Zealand's livery, on the other hand, called for a slightly different shade of white, a teal-blue tail with a white logo, and the words Air New Zealand at the front of the fuselage just above the window line, along with a few other minor variations. The repainting task was to be carried out by a team of painters from EAS Industries, who had completed a familiarization course for this aircraft model. Given the large size of an A320, the amount of paint required to cover it is considerable, and even a single coat adds more weight than one might expect. Applying too many new layers can significantly impact the aircraft's performance, so the repainting process typically involves stripping off the old layers using a chemical paint remover. However, on surfaces made from composite materials, the paint must be removed by sanding rather than chemicals. The team discovered that 2 different versions of the XL Airways livery had been applied over the previous bright orange Freedom Air International livery, and they soon realized that the available paint stripper was insufficient to fully remove all traces of this second hidden layer. As a result, the painting crew had to sand off a large number of sticky orange patches every time they stripped a new section of the aircraft. However, sanding the tops of the wings generated a significant amount of dust that rose and settled on the freshly repainted fuselage, which was problematic since the technical markings, registration numbers, warning signs, etc., had yet to be applied. Consequently, the The decision was made to rinse the dust off the aircraft before applying the technical lettering. Once the repainting process was completed, the verification flight was the only remaining task before Air New Zealand could take possession of the aircraft. At the controls of the flight, designated 888T, was Captain Norbert Keppel, 51, the airline's Director of Flight and Ground Operations, and First Officer Theodore Ketzer, 58. Each had around 12,000 flight hours. At the same time, several New Zealanders had traveled to Perpignan to assist in verifying the aircraft, including Air New Zealand Captain Brian Horrell, 52, 3 Air New Zealand engineers, and a representative from the New Zealand Civil Aviation Authority. A total of 7 people were aboard the A320. After several discussions between the captain and the control tower in which the planned test route remained unclear, it was finally agreed that the flight would head north, perform several high-altitude tests, and then conduct low-altitude tests during an approach to Perpignan Airport from the south. Upon landing, they would not stop, but instead take off again to head for Frankfurt. At 3:33 p.m., the aircraft began to accelerate down the runway. They took off without any issues and began climbing toward 31,000 feet, the first target altitude for initial checks. Once leveled off at that altitude, they conducted tests on communication, navigation, and flight control systems. With everything verified, they proceeded to climb again, this time to 39,000 feet, where they would test the auxiliary power unit located in the aircraft's service ceiling. During the descent, checks were planned for high and low-speed protection systems. At 3:48 p.m., as the flight was ascending into high-level airspace controlled by the Bordeaux Area Control Center, the controller there detected the flight and immediately grew concerned. Earlier that same day, a Boeing 737 from XL Airways had also attempted an acceptance flight from Perpignan under a regular flight plan, and the controller considered it problematic to perform such maneuvers without a designated test area. He quickly realized that Flight 888T was also a test flight and contacted the Perpignan Tower to ask why they had sent another one without prior notice. Seconds later, the crew reached the stage of the verification program requiring tests of bank angle limits, which would require course deviations, so the captain contacted the Bordeaux controller.
Could we maintain flight level 180 on heading 330 and do a couple of 360-degree turns? We're an acceptance flight, so it would be great if you could give us some airspace to perform a few procedures.
I'm afraid we can't allow test flights in general air traffic. Your flight is not designated as an OAT flight. After the denial, the crew began improvising. Once the navigation and communication checks were complete, they decided to return to Perpignan, as continuing toward the Bay of Biscay made little sense if air traffic control still wouldn't authorize the maneuvers upon arrival. But that didn't mean they wouldn't try to complete all the checks anyway. As they turned around, they carried out the bank angle tests while complying with an air traffic control clearance, confirming that the protections were working. Moments later, they began descending to flight level 250 while performing an overspeed test, pushing the aircraft into a descent and accelerating until the overspeed warning sounded. Continuing their descent, they completed the bleed air system checks, then tested flight controls in alternate law by turning off both FACs. Everything functioned as expected. At this point, time became tight. Once they reached 25,000 feet, They kept descending, struggling to fit all the tests into a compressed time frame due to the ATC's denial of a dedicated test area. By the time Captain Harrell brought up the low-speed test,
"First, we'll lower the landing gear. Flaps will go to full. We'll set engine power. And once the aircraft's speed stabilizes and power is set to idle, it'll be manual, and we'll adjust pitch to maintain a deceleration of about 1 knot per second."
You want to go down to VLS and then alpha protection, right?
Exactly.
To clarify, VLS is the minimum selectable speed for the autopilot. After reaching this speed, they would switch to manual flight control to trigger alpha protection, the aircraft's safeguard against stalling at low speeds. In other words, if the pilot induces a stall, as Captain Keppel intended to do, the aircraft is designed to override and prevent it from happening. Moments later, Flight 888T maneuvered to approach Perpignan Airport and was cleared to descend to 6,000 feet. 2 minutes later, they reached 2,000 feet and emerged from the clouds, so they began the low-speed test.
Landing gear down.
First Officer Ketzer extended the flaps to the landing configuration, and Keppel climbed and leveled off at 3,000 feet to begin slowing the aircraft. They gradually began losing speed. Captain Harrell, with the data in hand, kept his eyes fixed on the aircraft's speed. He held the figure indicating when the A320's alpha protection would activate, a value he had not shared with the pilot in command at any point. Seconds later, their airspeed reached the threshold marked as the alpha protection speed. But the alpha protection didn't activate, and engine thrust didn't automatically increase as everyone expected. Moments later, they reached the minimum lift speed. Stall warnings began sounding in the cockpit, yet alpha protection still failed to engage.
Stalled.
As soon as Captain Harrell recognized the stall warning, he shouted, "Stop!" At the same time, Captain Keppel pushed the thrust levers forward to increase power. But by the time the engines responded, the airspeed had plummeted to 92 knots, and the aircraft began to lose lift. At that moment, they were dangerously close to the water. As the stall developed, smooth airflow over the wings ceased, causing the aircraft to become unstable in roll, resulting in a sudden bank to the left. Captain Keppel executed the standard stall recovery maneuver, which involves applying takeoff power and maintaining a pitch angle between 0 and 5 degrees. Normally, this should prevent the angle of attack from exceeding the stall threshold, and for a brief moment, it seemed to work. The stall warning stopped, and airspeed began to increase. But the combination of maximum power and a slight pitch-up led to a steep and unsustainable climb. Keppel pushed the control stick forward to counter it, but the full power setting made it impossible to level the aircraft. As the aircraft climbed, its speed dropped again, and Keppel exclaimed in German, "It increased speed, right?" The first officer asked Captain Keppel, "Are you able to handle this?" To which the captain replied clearly, "No." The warning sounded again as they approached a second stall in under 30 seconds. Moments later, the aircraft fully stalled, reaching an extreme pitch of 57 degrees and banking 59 degrees to the left. It peaked at 3,788 feet, but its airspeed fell below 40 knots, far too slow to sustain flight. The aircraft violently shuddered, lost lift, and began falling from the sky. As it did, the nose dropped and the speed began to rise, but there was little room left for recovery. As they descended and Captain Keppel tried to level the aircraft, the crew shouted various instructions in rapid succession to recover from the stall: deploy speed brakes, retract flaps. During this, The ground proximity warning system began to blare. Those were the last words recorded on the cockpit voice recorder. Moments later, at 15:46.7, with the nose pitched 14 degrees down and rolled 15 degrees to the right, with an increasing forward speed of 263 knots, Flight 888T crashed into the Mediterranean Sea 5 kilometers off the coast of Perpignan, instantly destroying the aircraft and killing all 7 people on board. What had happened? Why did the A320's alpha protection fail? Numerous witnesses on land and at sea observed the A320's final plunge, including the crew of a yacht just 500 meters from the crash site. These witnesses quickly alerted emergency services, which rushed to the scene but found nothing. In a cruel twist of fate noted by the airline's CEO, the crash occurred on the 29th anniversary of the infamous Air New Zealand Flight 901 disaster, the country's worst peacetime tragedy, adding further sorrow to an already dark date for the airline and the nation. The investigation, which involved more than half a dozen stakeholders, lasted nearly 3 years and concluded in July 2011. In short, the chain of events began when the team tasked with repainting the aircraft washed it with a high-pressure fire hose to remove dust from the fuselage in preparation for applying technical markings. The first major error came on the ground, by EAS Industries. Airbus had known since the early 1990s that if angle of attack AOA sensors were not covered during washing, water could enter the sensor bearings. This warning was explicitly detailed in 2 letters sent to operators in 1993 and 1998. Moreover, Airbus's cleaning and painting procedures, which EAS used as the foundation for its repainting process, included specific instructions to prevent this issue. However, the painting supervisor did not consult the documentation, even though it was readily available, because he didn't consider washing the aircraft to be a maintenance action that required adherence to specific procedures. This was not just a lapse in judgment, it was a training failure as well. Water entered the AOA sensor bearings, and once the aircraft reached cruising altitude, it froze, jamming 2 of the 3 sensors. These sensors then fed faulty data to the flight control systems, preventing the alpha protection from functioning properly and allowing the A320 to stall. On the administrative side, investigators noted that the concept of an acceptance flight existed in a regulatory gray area with no official definition. Such verification flights were commonly carried out worldwide in connection with lease agreements, but there were no applicable standards, and they were often arranged ad hoc. The lack of planning and procedures for acceptance flights was evident in XL Airways' failure to obtain proper clearance to conduct such a flight in French airspace. It is crucial to highlight that 3,000 feet is far too low an altitude to test low-speed protections. If the aircraft stalls at that height, there may not be enough space to recover, something this crew learned in the worst possible way. Conducting that test at such a low altitude was completely inappropriate, reckless, and extremely dangerous. Another major point was the absence of any contingency plan in case the low-speed protections failed. During formal Airbus test flights, test pilots are trained to anticipate potential system failures and to have backup strategies. But the Air New Zealand verification program, modeled on a demonstration flight procedure, did not include such guidance. In its final report, France's Bureau of Inquiry and Analysis, BEA, recommended stricter regulations for test flights and more effective training in stall recovery procedures. Since then, significant changes have been implemented in pilot training, influenced by several accidents including XL Airways Germany Flight 888T. In fact, none of the pilots on this flight had received specific training in handling abnormal flight conditions, training that is now mandatory in most countries.